In this video, we are going to find equation of 3D line. 3D line passing through the 2 points. There are the 2 points. For example, this is a 3D line and this 3D line passing through the 2 points, point A and point B. So these are the 2 points given on the 3D line. There are the 2 types of lines. One is a 2D line, 2D line, 2-dimensional line. Another is a 3D line, 3-dimensional line. So there are the 2 types of lines. So today's video, I'm going to talk about how to find the equation of 3D line if it is passing through the 2 points, point A and the point B. Now consider the 3 axes, x-axis, y-axis and z-axis, and it is a origin. Now join the origin with the point A and point B, join to the origin, and let us call their position vectors. The position vector of point A is vector A and position vector of point B is a vector B. So we had considered the 2 points, the 3D line. This is a 3D line, 3-dimensional, and it is passing through the 2 points, point A and point B, and their position vectors are vector A and the vector B. Now we'll consider a point P on line AB. So this is a point P. It is any point present between the point A and point B. It can be anywhere. Now join again origin and the point P, and let us call the position vector of point P is a vector R. Vector A is the position vector of point A, vector B position vector of point B, and vector R position vector of point P. So vector AP and vector AB, they are collinear vectors. Why? Because point P is present between A and B anywhere, so that the vector AP and vector AB are collinear vectors. Now they are related by relation. Vector AP equals to lambda multiplied by vector AB. To make them equal, we have to multiply one of the vector by some scalar. So the scalar multiple of vector AB is equals to vector AP. Lambda is any scalar value, any suitable vector, any suitable scalar value. So it is a scalar. Any scalar value that is suitable such that vector AP becomes equal to lambda into vector AB. Both vectors become equal. So that balancing number is nothing but lambda. So it is a scalar multiple. Now vector AP is nothing but difference of position vector of point P minus position vector of point A. Similarly, vector AB equals to position vector of point B minus position vector of point A. Therefore, vector AP is nothing but position vector of point P, that is vector R, minus position vector of point A, that is nothing but vector A. So this is a position vector of A, this is position vector of P, and it is vector B is a position vector of point B. Therefore, vector AP equals to vector R minus vector A. Similarly, vector AB, that is position vector of B, that is vector B, minus position vector of A, that is vector A. Therefore, we have vector AP equals to vector R minus vector A, and vector AB equals to vector B minus vector A. Since vector AP equals to lambda into vector AB, now putting the vector AP, that is vector R minus vector A, equals to lambda multiplied by vector AB, that is vector B minus vector A. Now simplifying, vector R minus vector A equals to lambda multiplied by vector B minus lambda multiplied by vector A. Now taking the vector A to the right side, so we get vector R equals to lambda multiplied by vector B minus lambda multiplied by vector A plus vector A. So vector R equals to lambda multiplied by vector B plus vector A taken common, 1 minus lambda. We can write the same equation in more simple way. Instead of opening the bracket, we can keep it without opening the bracket as it is, only taking vector A to the RHS side. That is vector R equals to vector A plus lambda multiplied by vector B minus vector A. So instead of opening the bracket, if you keep it as it is, it looks more simple and easy to remember. To support above concept, above theorem, let us take one practical example. Find the equation of line passing through the point A 3 to 1 and point B 2 3 4. Solution. We'll draw the rough diagram here. The point A and point B, coordinates of point A are given as 3 2 1 and coordinates of point B 2 3 4. Consider any point P present on the line with position vector R. Vector R be the position vector of point P. Now A is nothing but vector A, nothing but position vector of point A. So that is equals to, the point A is given by 3 to 1. So position vector of point A is nothing but 3I cap plus 2J cap plus K cap. Similarly, the position vector of point B, coordinates are 2 3 4. Therefore, position vector of point B equals to 2I plus 3J plus 4K. Now, equation of line AB. Equation of line AB. This is 3D line. So this is 3D equation. So 3D equation of line AB is given by vector R equals to vector A plus lambda multiplied by vector B minus vector A. Lambda is any scalar multiple. Putting these values, so we get vector R equals to 3I plus 2J plus K plus lambda, and difference of vector B and vector A, that is 2I plus 3J plus 4K minus vector A, that is 3I plus 2J plus K. Therefore, vector R equals to 3I plus 2J plus K that is a cap I cap, j cap and k cap plus lambda minus I plus j n plus 3k. So this is required equation of line AB. Of course, it is 3D equation.